One of the most anticipated galactic occasions is the Betelgeuse cosmic explosion, situated on the prominent shoulder of Orion. Betelgeuse is a red supergiant star approaching the end of its life. Peculiarly, in 2019, Betelgeuse, one of the most splendid stars overhead, started to dim. The dimming was perceptible to such an extent that it could be seen even without extraordinary optics for a couple of months. Betelgeuse diminished until onlookers began to wonder if the star had died. When researchers focused their most powerful telescopes on the red supergiant star, they were stunned to see evidence of the incredible dimming. Despite this, the star's brightness returned to normal after a couple of months. This star is going to explode as its life cycle comes to a conclusion. When and why might a cosmic explosion occur, and will it have deplorable ramifications for Earth? We should investigate. Music. The splendid ruby-red star Betelgeuse is situated in the upper right shoulder of the winter constellation Orion the Hunter. You might know it better by its alternative name, Alpha Orionis. It is the second most splendid star in the constellation, directly behind the blue supergiant Rigel. Betelgeuse is a fascinating object for astronomers to observe and study due to its variable behavior and unconventional nature. Alpha stars are generally the most brilliant in their star groupings, and this is true even though Rigel, Orion's other great star, is more brilliant because of its name. In terms of size and reddish color, Betelgeuse, also known as Alpha Orionis, is arguably one of the most renowned stars in the sky. It is the 10th most brilliant star overhead and the 7th most brilliant star apparent from most of North America, Europe, and Canada. The name Betelgeuse comes from an Arabic word that means the armpit of the giant, which is a frequent translation of the name. Betelgeuse's actual distance from Earth is unclear. However, researchers believe it to be somewhere in the range of 430 to 724 light-years. To lay it out plainly, Betelgeuse is the most brilliant and closest red supergiant star to Earth. There are only around 200 red supergiant stars known to exist in the Milky Way. Betelgeuse is multiple times the size of the Sun, emanating 126,000 times the amount of light as the Sun, and is visible from a distance of 548 light-years. It is cooler than the Sun, with a surface temperature of 3,600 Kelvin. About 133% of its total radiant energy is composed of visible light. Betelgeuse would be more glowing than Sirius if we could see light at all frequencies. It is estimated that Betelgeuse is nearly 1,000 times the Sun's radius. If this star were to take over as the Sun of our solar system, its impact would extend beyond Jupiter and the asteroid belt. This would result in the complete engulfment of Earth, Mars, Mercury, and Venus. Betelgeuse, a red star, loses around one solar mass every 10,000 years as material is shot out unevenly from the star, resulting in a cloud surrounding the star. Red supergiant stars, such as Betelgeuse, are approximately 30 cosmic units, AU, or multiple times the distance between the Sun and Earth, and they are multiple times bigger than the actual star at their core. A star's hydrogen particles combine under the impact of gravity, creating helium in a nuclear fusion process. Intensity and light are two types of energy that are frequently delivered in abundance during this fusion process. This energy advances toward the outer layer of the star, where it is ultimately released as a photon into the universe. Ultimately, the star will run out of its essential fuel, hydrogen, and will need to depend on helium and carbon for burning. When all the helium has been consumed, neon will react with carbon to produce iron. When this happens, the energy delivered by the combination of neon and carbon is consumed as iron forms inside the star. Its high gravity causes it to implode in on itself, setting off a cosmic explosion, driving 10 billion suns. A cosmic explosion is quite possibly one of nature's most powerful blasts. Depending upon their age and developmental stage, stars produce light of changing frequencies and temperatures, resulting in a range of colors from the blue of the most youthful stars to the red of the most ancient. By Ptolemy, a Greek researcher who lived from 100 to 168 AD, Betelgeuse's color was strangely portrayed as rosy. Anyway, old Chinese astronomers noticed that Betelgeuse seemed yellow, suggesting that it might have been a yellow supergiant in the past. Bigger stars often consume their hydrogen fuel more rapidly, leading to their inevitable destruction, even if they are only approximately 10 million years old. Historically, Betelgeuse is in its later phases of existence. However, at over 5 billion years of age, our Sun is still going strong. The star Betelgeuse is approaching the end of its existence, and that means it might go supernova at some point. However, the specific timing of this event is controversial. There are two patterns of dimming and brightening that occur on Betelgeuse, the second of which happens at regular intervals and lasts for about 100 days. There is a hypothesis that the star's external shell grows and contracts over this cycle, causing the star's diameter and average temperature to change at each stage. Many individuals focused on Betelgeuse because of its erratic dimming in 2019 and 2020, followed by a brief recovery to its normal brightness. Some astronomers have hypothesized that this could mean the star is dying. Broad investigation of Betelgeuse traces all the way back to the 1st century BC. However, the cause of its sudden and unusual fading remains obscure. Betelgeuse was detected speeding across the interstellar medium at a pace of 30 kilometers per second after being ejected from its home in the Orion OB1 association, which contains the stars in Orion's belt. The bow shock from this speeding star traverses more than 4 light-years. Distances to red supergiant stars like Betelgeuse are famously hard to ascertain in cosmology. Numerous factors make it difficult to compute Betelgeuse's genuine distance across the star. Betelgeuse's size changes over time because it is a variable star. Due to limb darkening, the star's visual emissions change in tone and dim as one moves away from its center. While attempting to characterize Betelgeuse's photosphere, it is vital to account for the circumstellar envelope, which is made up of material ejected from the star and absorbs and emits light. It is challenging to make direct comparisons between observations due to the star's apparent size changing with frequency. Widths can vary by as much as 35%, depending on the frequency used to measure them. In July 2009, the European Southern Observatory released images taken by the ground-based Very Large Telescope Interferometer, VLTI, which showed a massive gas plume extending $30 from the star into the surrounding environment, one of many mass ejections from Betelgeuse's atmosphere. This one had an extent equivalent to the angular diameter of the Sun and Neptune. At least 6 shells have been found by astronomers surrounding Betelgeuse. If the mystery of mass loss in the dying phases of a star's life could be solved, perhaps the cause of these celestial giants' heartbreaking downfall could be found. Betelgeuse's long environment and its complex elements have been addressed. Notwithstanding the star's size, the specific mechanism by which the material is lost from red supergiants is a mystery. However, they are crucial to the recycling of matter that forms galaxies. Thanks to recent advancements in interferometric techniques, cosmologists may soon find an answer to this problem. Scientists used Hubble and other telescopes to discover that in 2019, the star expelled a significant piece of its apparent surface and created a major surface mass ejection. Coronal mass ejections, CMEs, happen frequently when the Sun ejects pieces of its tenuous outer atmosphere, the corona. The power of these events is thousands of times lower than what was observed on Betelgeuse. The surface mass discharge from Betelgeuse ousted 400 billion times more mass than a common coronal mass discharge. This makes sense of why Creepy Crawly Juice started a fast diminishing in October 2019. By mid-February 2020, it had lost approximately 3 times the amount of brilliance, going from size 0.5 to size 1.7. By the 17th of February 2020, Bug Juice's brilliance had been very steady for over 7 days. However, by day 5, it created the impression that Bug Juice had quit diminishing altogether, really finishing the diminishing event. Ongoing visual blurring appeared to be profoundly inconsequential, as there were no significant changes in the infrared on February 24, 2020. Another review published on the same day inferred that huge grain circumstellar dust was probably going to fault for the star's diminishing. The review utilized submillimeter frequency estimations to preclude dust ingestion as a significant contributor. However, huge star spots seem to be responsible for the darkening. A more critical look showed that insect juice's iridescence had emphatically increased. The new significant fall in Betelgeuse's brilliance was connected to the discovery of a subsequent residue cloud rising out of the star on August 30, 2020. A cool region on its photosphere was conjectured to be the wellspring of the dust. In June of last year, and in August, a second independent assessment affirmed the principal findings. It is trusted that the gas shot out by the star as it cooled made the residue. Darkening residue might have been the consequence of a surface mass discharge, as indicated by studies from the Hubble Space Telescope in 2022. A large number of kilometers from the star's surface, the material catapulted from the star's surface cooled and compacted to become the star's winding down dust. The star's photosphere, which is a few times as massive as our moon, fell to pieces and cruised off into space, impeding it from Earth. The darkening, which started in late 2019 and went on for a couple of months, was recognizable even to patio stargazers. What's more, mind-blowing is that the very monster's heartbeat rate has stopped following 400 days of following this cycle. Cosmologists have been keeping track of Betelgeuse's surface movements and brilliance varieties for the past century or more. The power of the blast is reflected in the harm. Cosmologists have put out a hypothesis that could represent the aggravation. The star's photosphere is additionally being revived, so it's acquiring strength over time. The star's inside structure is vibrating like a broke bell as its normal cycle is upset. These discoveries shed light on the cycle by which red stars age and lose mass before their atomic fusion heaters dry up and they detonate as supernovae. What befalls them depends basically on how much mass they lose. The exceptionally malignant direct of Betelgeuse doesn't predict the star's quick ascent to unmistakable quality, so it's not always the case that a significant loss event signals an approaching blast. Specialists have stated that an enormous star's surface mass launch has never been found, proposing that there is something happening that we don't yet fathom. Hubble can assist us with spotting recognizable surface elements, for example, the continuous perception of star development, as we saw this up until recently concealed peculiarities. Interestingly, the catapulted material's infrared radiation is still on its way away from the star, so it might be identified by NASA's James Webb Space Telescope. At last, Betelgeuse's darkening has ended, and it might by turn into the 10th most brilliant star in the night sky. Betelgeuse, notwithstanding its huge span, is perhaps of the most brilliant star overhead, sparkling at just multiple times the brilliance of the sun. Keeping aware of Betelgeuse's tremendous energy requests requires quick fuel burning, which hurries the star's obliteration. When the star runs out of fuel and implodes under its own weight, it will detonate into a fantastic cosmic explosion. Then, for a period of a little while to months, Betelgeuse will turn out to be incredibly brilliant, maybe moving toward full moon levels. It will end up being clear as the day advances. Provided that this is true, when could we expect it? We most likely won't witness that in our lives, but no one knows without a doubt. It might happen tomorrow, or it could occur in 1,000,000 years from now. Will Earth be obliterated by the Betelgeuse cosmic explosion? Since Betelgeuse is so far away from Earth, its blast won't kill or even seriously disturb life here. As indicated by stargazers, the most secure distance from a cosmic explosion for human existence is 50 light-years, making creepy crawly juice over 10 times more remote. All things considered, everybody on Earth will get a show when a remarkably splendid star unexpectedly shows up in the sky. If it's not too much trouble, share your perspectives in the remarks. Thank you for watching this video. Until the end, if you preferred this video, like and subscribe to our feed for more like this. We have another very fascinating video prepared for you. Click on the video on your screen, and let us take you into another fantastic space experience.